Welcome to clickmyproject.com. Let me discuss about the process fast and robust spatially constrained Gaussian mixture model for image segmentation. Let me see the abstract of the process. The process of image segmentation is always affected by the presence of noises in the images. A segmentation method that segments the images even in the presence of noise is proposed. The segmentation process is initialized with the help of fuzzy partitioning of the images. Then clustering is employed to differentiate the image pixels. For clustering, FCM is employed. The EM and MRF models were applied to the cluster images to segment the images even in the presence of the noises. The performance of the process is measured with the help of accuracy and the error rate. Image segmentation is the process of obtaining the particular regions from the images. Edge detection, contour extraction, clustering are all the most common segmentation methodologies employed. Edge detection identifies the edge points around the needed objects. Contour extraction refers to the outlining of the segmented portions from the images. Clustering based methodologies segments the regions by grouping the pixels that have similarities in any of the cases such as intensities or color, etc. The process of the image segmentation is always affected by the presence of noises in the images. The clustering based FCM method improves the overall performance of the process. The noises in the input images is initially undergone fuzzy partitioning. The fuzzy partitioning identifies the different intensities of the images. The intensity differences were identified and clustering is employed to separate the different clusters. The clustering process is based on fuzzy C-means. The cluster regions were then segmented using GMM model. The likelihood measures the cluster regions were maximized with the help of the EM algorithm. In EM algorithm, the Gaussian distribution at each pixel ranges were measured. The Markov random model is employed using the identified maximum likelihood estimated using the EM model, which gives the maximum likelihood information. The Gaussian mixture model is employed with the likelihood information obtained using the EM model to cluster the input images into clusters. The performance of the process is finally measured by measuring the accuracy and error rate of the segmentation process. Now we see the flow of the process. First, in the input images, noises were added and the noisy images generated. So the generated noisy images were undergone fuzzy partitioning. In fuzzy partitioning, the rules were generated using fuzzy rules. The fuzzy rules are helpful in the differentiation of the noisy pixels in the images. The noisy and the other region pixels identification were helpful in the clustering of the image portions. K-means clustering is employed in order to cluster the normal image pixels in the images. The clustering of the image pixels other than the noisy pixels were helpful in the separation of the noisy and the noiseless image pixels. After fuzzy partitioning, clustering process is employed. In the clustering process, the regions in the images that were having similar intensities is clustered using fuzzy C-means algorithm. In fuzzy C-means, every point has the degree of belonging to the clusters, as in fuzzy logic, rather than belonging completely to just one cluster. Thus, the points in the edges of the clusters may be in the cluster to a lesser degree than the points in the center of the cluster. An overview and comparison of the fuzzy clustering methodologies can be employed based on the differences in the membership functions employed in the process. Any point in the images having the set of coefficients that were having degree of being the kth cluster with fuzzy C means the center of the cluster is the mean of all the points weighted by the degree of the belonging to the cluster. Each cluster region represents the different intensity regions, and finally we get three clusters obtained. After that, EM model is up. So in the EM model, the clustering regions were estimated. The EM model identifies the posterior probabilities and the period distributions. The identified distributions and the probabilities were then combined, and the identified pixel ranges were then combined to obtain the maximized probabilities of the regions. The identified probability and the posterior probability were then taken. The mean value of the neighboring pixels were then combined and the pixels were selected. The selected pixels based on the identified mean value of the neighboring pixels were then grouped and the regions were represented. So as a result of this, the maximized probability of the regions were estimated. After that, the GMM model is employed. So the GMM model is a weighted sum of the M component of the Gaussian densities. The complete Gaussian mixture model is parameterized by the mean vectors, covariances and the mean weights of all the component densities. The covariance matrices can be a full rank or constrained to be diagonal. Additionally, the parameters can be shared or tried among the Gaussian component. The choice of the model configuration, that is the number of covariance matrices components, were determined by the amount of data that is given as the input. Then as a result of GMM, the segmented portions were obtained. Finally, the overall performance of the machine is measured by the accuracy of the process. So the accuracy is measured by comparing with the ground images. Let us see the flow of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the images that were followed. So browse any one of the images and select open. So after that, the noisy images were generated. In that, the iterations were started based on the partitioning of the input images. Then after that, the objective functions based on the GMM model were created. After the creation of the objective functions, the process is started. So as we can see, the after GMM model, the images were finely refined and the input noisy images were clustered like this. Then after that, as we can see in the Gaji Markov random model, first the images were clustered and after that in the GMO model the cluster regions were clearly estimated. So compared to this noisy images, the images were clearly obtained as a result. Finally, the performance of the process is measured based on the PSNR value and the, so this is the PSNR and the MSE values obtained in our, so the obtained PSNR value is plotted as, similarly the obtained MSE is also plotted as a, for some of the images, the while generating the objective functions, the variables will be none and hence the GMM model will be shown as empty. So in that cases, we have to close MATLAB and restart the program again, so we can get the images again. Hence we develop a efficient clustering model which is based on the now even in the presence of noises, the images were clustered efficiently, which is based on Markov random and the GMM model. Thank you.